Absolutely. Here's a deep, detailed, but still super simple summary of everything you need to know about average. A summary so clear that you won't find better anywhere else. 1. What is an average? The average is a single number that shows what is normal or typical in a group of numbers. When people say average, they usually mean the arithmetic mean, which is calculated by adding all the numbers and dividing by how many numbers there are. The average helps you summarize many numbers with just one number, making it easy to understand a lot of information quickly. 2. Why do we use average? When you have many numbers, like students' marks, daily temperatures, salaries, it's hard to make sense of all of them one by one. The average gives a quick idea of what's going on overall. It helps you answer questions like, how much does a typical student score? What's the usual temperature this month? How tall are kids on average? 3. How do you find the average, arithmetic mean? Steps to calculate average. Step 1. Add up all the numbers. Step 2. Count how many numbers you have. Step 3. Divide the total by how many numbers there are. Formula: text average, mean, frac text, sum of all numbers, total number of numbers. Task 4. Simple example: marks of 3 students, 50, 70, 80. Sum of marks equals 50 plus 70 plus 80 equals 200. Number of students equals 3. Average equals 203, 66.67. So the average mark is 66.67. 5. Important truths about averages. The average does not mean every value is the same as the average. If average age is 12, it doesn't mean every child is 12. Some might be 10, some 14. The average lies between the lowest and highest values in the data. The average can be affected by extremely big or small numbers called outliers. For example, if one student scores 0 while others get 90, the average drops a lot. 6. Why is average called measure of central tendency? Central tendency means a number that shows where the middle or center of the data is. The average shows the balance point of the data. It tells you what's happening in general. Nav 7. Examples of average in real life. School, average marks of students in a class. Weather, average rainfall in a month. Sports, average runs scored by a cricketer. Daily life, average amount of time spent watching TV per day. 8. What do these everyday statements about average really mean? Each on an average 5 hours studying day studies less than 5 hours, some days more, but usually around 5. Average temperature is 40 degrees Celsius, some days cooler, some hotter, but mostly around 40 degrees Celsius. Average age of students is 12 years, some students younger, some older, but middle point is 12. Average attendance is 98%. Attendance is usually near 90, some less or more. 9. Different types of averages. Just a glimpse. Mean, the arithmetic average, what we just learned. Median, the middle value when you put the data in order. Mode, the number that appears the most. Different types of data need different types of averages, which you'll learn later. 10. Why is average so useful? It helps compare groups easily, e.g., which class or team did better. It simplifies information, so anyone can understand a big set of numbers. It helps make decisions, e.g., if average sales are going down, business needs to improve. Deepest takeaways. The average gives a quick, clear summary of a group of numbers. It shows what is typical or normal for that group. It's a measure of central tendency, tells you the center or balance point of the data. It's everywhere in daily life, studies, weather, business, sports. That's your complete, detailed, yet super simple summary of everything about averages. Would you like to learn how to calculate averages from word problems, or how median and mode work compared to the average? Absolutely. Here's a great, deepest, yet simplest detailed summary of everything about the arithmetic mean, explained step by step with no confusing words, so you get a complete and clear understanding. This summary ties together what arithmetic mean is, how to find it, why it matters, and where it lies. 1. What is arithmetic mean? Arithmetic mean, also called mean or average, is a way to find one number that represents all the numbers in a group. It shows what is normal, typical, or central among the numbers. It is like asking, if we share everything equally, how much does each one get? 2. How do you calculate arithmetic mean? You always follow 3 easy steps. Step 1. Add up all the numbers, sum them. Step 2. Count how many numbers there are. Step 3. Divide the total from step 1 by the count from step 2. 3. Formula for arithmetic mean. The mean is calculated using this simple formula. Text sum of all numbers, text number of numbers. 4. Why is arithmetic mean useful? It helps you summarize many numbers with one simple number. It makes it easy to compare different groups. It shows the central value, helping you see what's happening overall. It's used in schools, sports, science, business, weather reports, and many more areas. 5 easy examples. Example A, cups of milk. First cup 20 litres, second cup 60 litres. Add 20 plus 60 equals 80 litres. Divide by 2 cups, 80 over 2, arithmetic mean equal 40 litres per cup. Example B, student study hours. Ashish studies 4, 5 and 3 hours on 3 days. Add 4 plus 5 plus 3 equals 12 hours. Divide by 3 days. 12 over 3 equals 4 hours. Arithmetic mean equals 4 hours per day. Examples run scores 36, 35, 50, 46, 660, 6 plus 35 plus 50, 40, 60, 55, 282 runs. Divide by 6 innings, 282 word of 6 equals 47 runs. Arithmetic mean equals 47 runs per inning. 6. Where does the arithmetic mean lie? The arithmetic mean always lies between the smallest and largest numbers in the group. For example, numbers 10, 30, 50, lowest 10, highest 50. Mean 10 plus 30 plus 53 equals 90, 93 equals 30. The mean 30 is between 10 and 50. Arithmetic mean tell us? It shows what each item would have if everything equally. It is typical or usual for the group. It gives a single value that represents the whole set of number. 8. Important facts about arithmetic mean. The mean uses every number in the data. A very big or small number, called an outlier, can change the mean a lot. The mean is a measure of central tendency. It shows where the center of your data is. 9. Where do we use arithmetic mean? In school, average marks of students. In sports, average goals or runs scored. In weather, average rainfall or temperature. In business, average sales or profits. In health, average heart rate or calorie intake. 10. Super simple visualization. Think of it like sharing sweets equally. You have 10 sweets and your friend has 6. Together, 10 plus 6 equals 16 sweets. 2 people, 16 with 2 equals 8 sweets each. The arithmetic mean equals 8 sweets. 11. Keywords to remember. Sum total of all numbers. Number of observations, how many numbers you have. Mean, average, what you get by dividing the total by the count. 12. Quick recap. How to find arithmetic mean. 1. Add all numbers. 2. Count how many numbers. 3. Divide total by count. Result is the arithmetic mean. Deepest takeaways. Arithmetic mean shows the center of the numbers. It tells you what is normal or typical. It is found by adding all numbers and dividing by how many there are. It always lies between the smallest and largest numbers in your data. It's one of the most important tools in math, science, and everyday life. That's your deepest, simplest, most complete summary of arithmetic mean. Everything you need to know in the clearest words possible. Would you like some practice problems with step-by-step solutions? Absolutely. Here's a great, deepest but simplest detailed summary of everything you just learned, explained clearly step by step, covering where the mean lies, finding numbers between numbers, the concept of range, and how these ideas help you understand data. This summary brings it all together so you can see the big picture, but in easy words. What is the mean? The mean, also called arithmetic mean or average, is a single number that represents a whole group of numbers. It shows what would happen if you shared everything equally. You calculate it by adding all the numbers and dividing by how many numbers you have. Why is the mean important? It tells you what is normal or typical in your data. It makes it easier to compare different groups, like average marks of 2 students or average runs of 2 players. It helps you see the center of the data. Where does the mean lie? The mean always lies between the smallest and largest number in your data. It cannot be smaller than every number. It cannot be bigger than every number. It must be somewhere between the highest numbers. Examples. Numbers 4, 7, 10, smallest 4, largest 10, mean 4 plus 7 plus 10, either 3 equals 21 minus 3 equals 7 minus 7 is between 4 and 10. Numbers 5 and 11, mean 5 plus 11 by 2, 16 by 2 equals 8. 8 is between 5 and 11. This is always true. The mean will never be outside the range of your data. Finding numbers between 2 numbers. Once you know how to find the mean of 2 numbers, you can keep using it to find more and more numbers between them. By finding means again and again, you can show that there are infinite numbers between any 2 numbers, even fractions. Example. Between 0.5 and 0.8, first mean 0.5 plus 0.8 by 2 equals 0.65. 0.665 is between 0.5 and 0.8. Then mean of 0.5 and 0.65, 0.5 plus 0.65 by 2 equals 0.575, between 0.5 and 0.65. Then mean of 0.65 and 0.8, 0.65 plus 0.8 with a 2 equals 0.725, between 0.65 and 0.8. You can keep going forever. There's no limit to how many numbers you can find between 2 numbers. Range, what does it mean? The range tells you how much your numbers are spread out. You find it by subtracting the smallest number from the largest number. Formula, text range equal text largest number, text smallest number. Example, teachers' ages. Teachers' ages 32, 41, 28, 54, 35, 26, 23, 33, 38, 40. 1 arrange in order 23, 26, 32, 33, 30, 35, 38, 40, 41, 54. Smallest age 23, 3 largest age 54, 4 range 54 to 23 equals 31. So the range of ages is 31 years. Why is range important? The range shows you the difference between the highest and lowest numbers. It helps you understand how spread out the data is. Small range, numbers are close together. Big range, numbers are very different from each other. Example of small versus big range. Marks 78, 79, 80. Range equals 80, 78 equals 2. Small range scores are similar. Marks 45, 80, 98. Range equals 98. 45 is 53. Big range scores are very different. How do mean and range work together? Mean shows the middle of the numbers, average. Range shows the spread, how far apart the numbers are. Together, they tell you a lot about your data. If the mean is 50, but the range is 90, your numbers go from very small to very big. If the mean is 50, but the range is 5, your numbers are all close to 50. Big ideas to remember between the smallest and largest numbers. By finding means again and again, you can find infinite numbers between 2 numbers. The range shows how spread out the numbers are. Mean and range together help you understand and compare data easily. Super simple final summary. Mean, add all numbers and divide by how many tells you the center. Range, largest, smallest, tells you the spread. Mean is always between the smallest and largest. There are infinite numbers between any 2 numbers found by taking their mean again and again. Just easy, complete summary of where the mean lies, how to find numbers between numbers, what range is, and why these ideas matter. Would you like me to create practice problems or visuals to help you understand even better? Absolutely. Here's a great, deepest but simplest possible detailed summary of everything you just learned about mode, explained clearly, step by step, with every key point so you see the big picture. This summary pulls everything together so you'll never forget what mode is, how it works, and why it's important. What is mode? The mode is the value that appears the most in a set of data. It shows what is most common, most frequent, or most popular among the observations. Unlike mean average, the mode is found by counting how many times each value occurs, not by adding or dividing. Why is mode useful? The mode helps you know what people prefer, choose, or buy the most. It's useful in real-life situations like knowing which shirt size sells the most in a clothing store, finding out the most common exam score in a class, seeing which food item people order the most at a restaurant. Shirt size example in detail. A shopkeeper sells shirts in 5 sizes. 90 centimeters sold 22 shirts, 95 centimeters sold 8 shirts, 100 centimeters sold 32 shirts, 105 centimeters sold 37 shirts, 110 centimeters sold 6 shirts. Total shirts sold equals 105. If he calculates the mean shirts per size, mean equals total shirts sold of number of sizes. Mean equals 105 per 5 equals to 21 shirts per size. But stocking 21 shirts of each size won't match what customers actually buy. Some sizes sell more than 21 shirts. Some sell much less. So the mean doesn't help him know what sizes to stock more of. Looking at the numbers, the highest sales were for 105 centimeters, 37 shirts. So the mode is 105 centimeters because it sold the most shirts. This tells the shopkeeper to keep more shirts of 105 centimeters since that's the most popular size. Key characteristics of mode. Mode tells you what happens the most times. Mode can be used for numbers, like scores, prices, and categories, like shirt sizes, ice cream flavors, favorite fruits. Mode is especially helpful when you need to know what choice is the most popular. Important things about mode. Mode does not need any calculation like adding or dividing. You just count which value appears most. Data can have one mode, unimodal, one most common value, 2 modes, bimodal, 2 values are equally most common, more than 2 modes, multimodal, 3 or more equally common values. No mode when all values appear the same number of times. Examples of different cases: unimodal 3, 3, 4, 5, mode 3 appears most often. Bimodal 3, 3, 5, 4, modes equals 3 and 5, both appear twice. No mode 1, 2, 3, 4, all numbers appear once, no mode. Other simple examples. Example 1, scores. Numbers 5, 6, 6, 7, 8. Mode equals 6 because 6 appears twice more than others. Example 2, favorite fruits. Responses: apple, mango, mango, banana, apple, mango. Mango appears 3 times. Mode equals mango. Differences: mode versus mean versus median. Mean, add all numbers, divide by how many average value. Median, middle number when numbers are lined up from smallest to largest. Mode, number or item that happens most often. Each gives different information about your data. When to use mode. Use mode when you want to know what people buy the most, shopping. What marks or grades most students got, education. What choice most people make, surveys, polls. Simple formula for finding mode 1. List all your numbers or items. 2. Count how many times each appears. 3. The one with the highest count is your mode. Super simple final summary. The mode is the value that happens the most times. It shows what is most common or popular. Mode can be used for numbers or categories. Mode helps you decide what people want most, like the most, or choose most often. That's your deepest, clearest, most complete summary of mode in simple words so you understand perfectly. Would you like to try a quiz or press problems to test your understanding of mode? Absolutely. Here's your great, deepest, and most detailed summary, explained in the simplest words so you get every single important idea clearly and remember it forever. What is mode? Mode is the number or item that appears most often in a set of data. Mode shows what is most common, most popular, or happens most frequently. Unlike mean, which gives average, or median, which gives middle value, mode tells you what comes up the most times. Can there be more than one mode? Yes. If one number appears most, it's unimodal, one mode. If two numbers both appear most, it's bimodal, two modes. If three or more numbers appear most, it's multimodal, many modes. Example, numbers 2, 2, 2, 3, 3, 4, 5, 5, 5, 6, 6, 8, 2 and 5 both appear 3 times, most. So the modes are 2 and 5. This data is bimodal. Why is mode useful? Mode helps when you want to know what happens the most or what people choose most. For example, a shopkeeper wants to know which shirt size sells the most. Mode tells them. You want to find the most common height in your class, mode shows it. Planning a picnic, you ask everyone's favourite fruit, mode helps you pick the fruit most people want. Examples of mode in real life. Chapatis at a feast, people want 2, 3, 2, 3, 2, 1, 2, 3, etc. Mode equals 2 chapatis, most guests want 2 chapatis, but if you give everyone 2 chapatis, 2 25 equals 50, it's not enough because the total real need is 73 chapatis. Here, mode is not good because it underestimates the total. Shirt sizes in a shop. Sizes sold, 90 centimeters, 22 sold, 95 centimeters, 8, 100 centimeters, 105 centimeters, 7, 110 centimeters, 6. Mode equals 105 centimeters, 13 sold, most popular size. Here, mode is perfect because it shows what customers buy the most. Height of a door. If children are 130 tall, mode and 30 centimeters. Adults are taller, making a door only 100 meters high will hurt adults' heads. Here, mode is not to use maximum height or mean to make sure everyone fits through. Favorite fruit on a picnic. 20 people vote. 10 mango, 6 apple, 4 banana. Mode equals mango, most popular choice. If you can only buy one fruit, mode helps you pick what most people like. Important facts about mode. Mode works for numbers or words like scores, names, colors. Mode is found by counting how many times each value appears. Mode is easy to find, no adding or dividing needed. Mode shows what is most common, but not the average. When is mode not enough? Mode can be misleading if you need total or average. Example, number of chapatis needed. 2 per person, but adding everyone's needs shows you need more than 2 per person on average. Mean is better. Example, height of a door. Mode may match short kids, but ignores taller people. Maximum height or mean is better. When is mode perfect? Mode is perfect when you need to know the most popular choice, like most common shoe size sold in a store, most common shirt size customers must buy, favorite ice cream flavor in a group, the number that occurs most often in scores or survey answers. A summary of try these problems. Question 1, numbers. 12, 14, 12, 16, 15, 13, 14, 18, 19, 12, 14, 15, 16, 15, 16, 15, 17, 13, 16, 16, 15, 15, 13, 15, 17, 15, 15, 13, 15, 14, count, minus 12, 3 times, damn for 13, 4 times, 14, 5 times, 15, 8 times, mode 15, 9, 16, 6 times, others less. Question 2, heights. Heights given 160, 161, 162, 163, 4, 165, 168. Count 163 8 times, mode equals 163 centimeters. It means most children are 163 centimeters tall. When should you use mean or mode? Use mode when you care about the most common item, like most sold shirt size. Use mean when you care about averages, like average salary, average marks. Final, simple takeaways. Mode tells what happens most often, perfect for finding what is most popular. A set of numbers can have one mode, 2 modes, or many modes. Mode is easy, no adding or dividing, just count and find the highest frequency. Mode can be good or bad, depending on what you need. Good, when you need the most common choice. Bad, when you need an accurate total or average. That's your deepest, most complete, easiest to understand summary of mode. Everything you need, explained in the simplest way possible. Would you like me to help with more examples, or do you want to try a quiz on this? Absolutely. Here's your great, deepest and most detailed summary of median in the simplest words possible, so you understand everything perfectly and remember it forever. What is median? Median is the middle value of a set of numbers arranged in order, from smallest to largest or largest to smallest. Median splits data into two equal halves. Half of the numbers are below the median. Half of the numbers are above the median. Why is median important? Median shows the middle point of your data. Median is not affected by extreme values, very high or very low numbers. Example, if most people earn around 20,000, but one person earns 1 crore, the average mean shoots up, but the median stays close to 20,000, giving a better picture of what's typical. Median helps you divide things evenly, like making equal teams based on heights or marks. How to find the median. 1. Arrange the numbers in order. Always start by putting the numbers from smallest to biggest, ascending order. 2. Check if you have an odd or even number of items. If odd, median is the middle number. If even, median is the average of the two middle numbers. Example, odd number of items, numbers 17, 18, 24, 25, 35, 36, 46, number of items 7, odd. Middle position, 7 plus 1 by 2 equals 4, so the fourth number is the median. Counting 117 to 18, 3 to 4, 25, median. So median equals 25, 5. Example, even number of items, numbers 5, 9, 11 items, 4, even. Middle positions, second and third numbers, because 2, second and third, second, 9, third number, 11 median equals 9, so median equals 10 tall. Big example, heights of 17 students. Heights, symbol 106, 110, 123, 125, 117, 120, 212, 115, 120, 120, 115, 115, 115, 109, 115, 101. Step 1. Arrange in ascending order. 101, 101, 102, 106, 109, 110, 110, 112, 115, 115, 115. Of course, here's your greatest, deepest, most detailed summary of bar graphs and choosing scales, explained in the simplest words so you'll never forget it. What is a bar graph? A bar graph is a way of showing numbers using bars. Each bar represents something, like a color, fruit, students' marks, etc. The height or length of a bar shows how big the number is. Bar graphs help us see data quickly and compare different items easily. Why do we use bar graphs? To organize information clearly so you can see patterns, to compare things like which student scored highest or which fruit is most liked, to answer questions fast without looking through long lists of numbers. Example, if you want to know which snack is most popular among your friends, a bar graph shows you instantly by the tallest bar. Steps to make a bar graph. 1. Collect data. Example, students' favorite colors. 2. Make a frequency table, like this. Color, number of students, red 43, green 19, blue 55. 3. Choose axes. Draw horizontal line, x-axis, items, colors, names, etc. Draw vertical line, y-axis, number. 4. Choose a scale. Scale tells you how much each step on the y-axis represents. Example, 1 unit equals 10 students. 5 drawbars. Each bar starts at 0 and goes up to the number it represents. 6. Label everything. Write what each bar shows, like color names. Give a title to your graph. What is a scale in bar graphs? The scale shows how big each step on the y-axis is. It helps you fit the bars nicely on the paper. Without a scale, you wouldn't know what the bars mean. Example scales, small numbers, 1 unit equals 1 or 5. Medium numbers, 1 unit equals 10. Big numbers, 1 unit equals 50 or 100. How to choose the best scale? Find the biggest number in your data. Make sure the scale goes a bit higher than your biggest number so all bars fit. Choose steps like 10, 20 that make it easy to read. Example, if the highest number is 55, go up to 60 with steps of 10, 0, 10, 60. If you choose a scale too small, bars will go outside the page. If scale is too big, bars will look tiny. Reading a bar graph. Look at the labels on the x-axis, tells what each bar shows. Look at the scale on the y-axis, tells how much each bar stands for. Check bar heights. Taller bars mean bigger numbers. Bar graph example. Favorite colors data. Red 43, green 19, blue 55, yellow 49, orange 34. Draw x-axis, right colors, red, green, blue, yellow, orange. Draw y-axis, scale from 0 to 60 with steps of 10. Draw bars, red bar up to 43, green bar up to 19, blue bar up to 55, tallest, yellow bar up to 49, orange bar up to 34. From the graph, most preferred color, blue, tallest bar, least preferred color, green, shortest bar, total colors 5, count the bars. Key things about bar graphs. Bars must be of equal width so the graph is fair. There must be equal spaces between bars. Bars can be vertical, up, or horizontal sideways. Meaning is the same. The tallest bar shows the biggest number. If bars show how many times something happens, the tallest bar shows the mode, most frequent. Bar graph example. Marks of 6 students. Marks out of 600. Ravi 450, Salma 480, John 510, Meena 390, Priya 540, Usha 420. Steps 1. X-axis names, Ravi, Salma, etc. 2. Y-axis numbers up to 600. 3. Choose scale 1 unit 50 marks. 4. Draw bars to show each student's marks. 5. Label names, scale and title the graph. From this graph you can see who scored highest, Priya 540. Who scored lowest, Meena. Benefits of using bar graphs. Makes big lists of numbers easy to understand. Helps you compare things in a flash. Shows patterns like which item is most or least common. Turns boring data into a clear visual picture. Super simple takeaways. Bar graphs show data using bars. Choosing a good scale makes the graph easy to read. Bar heights tell you the numbers. Now the tallest bar shows the biggest number. The shortest shows the smallest. Bar graphs help you understand, compare, and answer questions quickly. That's your deepest, clearest, most detailed summary of bar graphs and choosing a scale, explained simply so you understand everything perfectly. Would you like help practicing with your own bar graph data?